What if we could build computer brains inspired by our own, using materials just a few atoms thick? Welcome to Summarize Science, where we break down the latest research. Today, we're looking at a paper that does just that, creating a new kind of AI framework using MOS2 memristors. The big challenge with today's AI, like deep neural networks, is that they require enormous amounts of computational power and energy. This paper explores a more energy-efficient alternative called reservoir computing. The key idea is to have a fixed network, the reservoir, that processes complex data and only train a simple readout layer to interpret the results. The secret ingredient is an ultra-thin material called molybdenum disulfide, or MOS2. Researchers created two different types of memory devices, called memristors, from this single material. Devices made from a single atomic layer of MOS2 exhibited short-term memory, meaning they would forget information quickly. In contrast, devices made from multiple layers showed long-term memory, holding onto information like a permanent synapse. This short-term memory behavior is actually perfect for the reservoir part of the network. When an input signal, like a sound wave, is fed in, the device's electrical state changes dynamically. It temporarily holds a memory of recent inputs, allowing it to process information that changes over time. This creates a rich, complex representation of the input data without needing complex training. The long-term memory devices, made from multi-layer MOS2, were used for the readout layer. These act like the synapses in our brain, with their connections strengthened or weakened during training. By carefully applying electrical pulses, their conductance can be finely tuned, allowing the network to learn and store information permanently. So, how well did this atom-thick brain work? For the first test, researchers fed it audio recordings of people speaking numbers from 0 to 9. The system converted the sound into electrical signals, processed them through the short-term memory reservoir, and used the trained long-term memory layer to make a decision. Amazingly, this small network achieved an impressive 89.56% precision in recognizing the spoken digits. To prove its versatility, the team also tested the framework on a different task, predicting the next value in a complex, non-linear time series. This is like trying to predict a chaotic pattern. As you can see, the predicted values closely match the true values, showing the system's ability to learn and forecast dynamic behavior. So let's recap the incredible achievements here. Scientists have successfully built a complete reservoir computing system using a single 2D material for both short-term processing and long-term learning. This approach is far more energy efficient than traditional AI. This could pave the way for powerful, low-energy AI systems integrated directly into small devices, from smarter smartphones to advanced medical sensors. It's a huge step towards building computers that work less like a calculator and more like a brain.